Hello everybody, let's keep learning as domain analysis module of continuous system. Hello students, let's learn 4.6 system functions. The general form of the differential equation of an LTI system is n derivative of any t adding a0 yt equals to m derivative of bmft plus b0ft. We learned about the differential nature of the Laplace transformation before. It is the Laplace transformation of the n-order derivative of ft, which equals to Sn multiplied by Fs, subtracting sigma m equals 0 to m minus 1. S to the power of n minus 1 minus m multiplied by f0 negative m step derivative if ft is added when t is equal to. So when t equals 0 negative, the derivatives of the f0 negative are all zeros. If it is a zero-state response, then the order derivatives of y0 negative are equal to 0. At this point, the differential equation becomes Laplace transformation of the n-order derivative of ft. The corresponding is the n side of s multiplied by fs. Then the general form of the differential equation is made Laplace transformation at zero state on both sides. We will get an multiply s to the power of m plus a0 braces y s equals to bm multiply s to the power of m. We make as equal to as shown in the formula. bs is equal to, so ys is equal to bs multiplied by as by fs. Let's look at the definition of system functions. The image function of the system function as the zero-state response of the system. The ratio of the elephant function of the incentive is hs equals ys to more than fs. Equal to bs compared to as. Visible system functions are only associated with describing the system. Differential equation coefficients related, that is, only related to the structure of the system, component parameters, etc., and nothing to do with external factors such as incentives, initial conditions, etc. So the system function and the differential equation, there is a one-to-one correspondence. That is, the known differential equation sits on the system function. The same is the same. Known system functions can also obtain differential equations. Let's look at an example question. Known hs equals 3 plus s divided by s plus 3s plus 2. Write out the differential equation of the system. According to system functions, it's easy to write out the form of the system differential equation. Is a2yt plus a1t plus a0yt equal to b1ft plus b0ft. In the form of hs, we can easily get the differential equation of the system. yt plus 3 times yt plus 2 multiply yt equal to 3 times ft plus ft. That is the definition of system functions. Let's take a look. The search for the zero-state response of the system. Before, we got the image function of the system zero-state response. ys equals hs multiplied by fs. It's an image function of the system zero-state response. So, according to the convolution theorem, yt is equal to the convolution of ht and ft. Let's take a look. Quadrant function of the step hop response to gt. Relationship to the image function of the punch response ht. According to the definition of the punch response ht, then is when f equals to the t, the zero state response is the impulse response. We know that the Laplace sum t is transformed into 1. Then the elephant function to the impulse response is hs. Step response is defined as zero state response when ft is equal to epsilon t. The corresponding image function of the st is 1 over s. So the corresponding image function for the step response is hs in s. This step responds to the gt image function. The relationship with the image function of the punch response ht is 1 of s. Let's look at an example question. The differential equation that describes the consistent continuous system at linear time is yt plus 2 multiplied yt plus 2 multiplied yt equal to ft plus 3 multiplied ft response to the system. The impulse response is in the zero state response at f equal to delta t. So we are going to make a Laplace transformation on both sides. The initial state is 0. The result of Laplace transformation on both sides is to the power of 2ys. Add 2 multiply sys plus 2 multiply ys equal to fs plus 3 multiply fs. This results in hs equal to ys compared to fs equal to s plus 3 over s to the power of 2 plus 2s plus 2. Constant deformation of this type equal to the following two formulas. The original function corresponding to the first sub-step is e as negative t sine by cosine t. The original function of the Laplace transformation corresponding to the second part is 2 multiply e to the power of negative t multiply sine t. So ht we get its value is e to the power of negative t multiplied by cosine t plus 2 multiply e to the power of negative t multiplied by sine t. Well, that's where we are going to say thank you. Class is over. Thank you for listening.